Use the method of cylindrical shells to find the volume generated by rotating the region bounded by the given curve about the y-axis. Let's start with a sketch. We know that we're bounded by x equals 4, and we know that the square root of x looks something like this. It's going to go through the origin, 1, 1, and 4, 2. We want to rotate this about the y-axis. When we do that, it's going to wrap around here to the left and look something like this. From here, let's look at one cross-section of that shape. So if we're looking at this piece, we can see that the height of that rectangle is the square root of x. The width is delta x. Keep in mind that one slice is really a shell. It's a cylindrical shell that we've cut out of the main shape. Again, the height is the square root of x, and then the width of that slice of that shell is delta x. So the volume is the integral from 0 to 4 of the circumference, which is 2 pi x, times the height, which is, in this case, the square root of x, times that thickness of the shell, which is delta x, or dx. If we simplify this, we can rewrite this pulling out the constant 2 pi. We have the integral from 0 to 4 of x to the 3/2 dx. And now we integrate. So keep 2 pi on the outside. Integrating x to the 3/2, we get 2/5 x to the 5/2. And we want to integrate from 0 to 4. Plug in the upper limit. Two fifths times 4 raised to the 5/2. And then we will subtract, plug in the lower limit. 2/5 times 0 to the 5/2. And if we simplify this, we get 128 pi over 5, the volume of the solid. In this example, we will again use cylindrical shells to find the volume. We'll start with some point plotting to sketch these curves. Y equals x is pretty simple. We have 1, 1, 2, 2, 3, 3. And then the other curve, if we plug in 0, we have 0 minus 0. That's just the origin. If we plug in 1, 4 minus 1 is 3. If we plug in 2, we have 8 minus 4, which is 4. And then if we plug in 3, 12 minus 9 is 3. So we have this basic shape. And we want to rotate this around the y-axis. So our curve is going to look something like this. And again, we want to use cylindrical shells, so we'll look at one cross section. Keep in mind that that cross section is really a cylinder that we've taken out of this solid. the height of that cylinder is 4x minus x squared minus x. That's that top curve minus the bottom curve. And then the thickness is delta x, or dx. And we can simplify this height. This is really 3x minus x squared. The volume is in the integral from 0 to 3 times the circumference, 2 pi x, times the height, which is 3x minus x squared, and then the width, dx. Simplifying this, we can pull the constant 2 pi out of the integral, and we have 3x squared minus x cubed dx. Integrating this, we get x cubed minus 1/4 x to the 4th. And we integrate from 0 to 3. Next, we'll plug in those upper and lower limits. First, we plug in 3 cubed minus 1/4 times 3 to the 4th. Then we subtract, plugging in the lower limit. 0 cubed minus 1/4 times 0 to the 4th. And once we simplify all of this, we get 27 pi over 2.